Okay, ladies and gentlemen, let's talk about functions and graphs. Now, previously, we talked about how to give a function using tabular data. Now, to give a function using tabular data, we're going to make a table, x, and let's give a function about how much you make per hour. Let's assume you have a job that you make $9 per hour. With that, your function would therefore be y equals $9 times x. So in this case, we're going to say 9x. Now, from there, we're going to need some values. Now, in this case, negative values wouldn't make much sense, so let's just give 0, 1, 2, 3. Now, in this case, we're going to need to show our work. We're going to say 9 times 0, 9 times 1, 9 times 2, 9 times 3. And our y values that we're going to get out, or our f of x, because the way we read this is as a function of x, because it's a function and it involves the variable x. So we have 0, 9, 18, and 27. With that, we can do a couple things. I can answer the question, well, how much money would you make if you worked 3 hours? 27 bucks. If you ask me, well, how much money would I make if I worked 30 hours? Well, I'd take 9 times 30, and that would be 270. Of course, that would be before the government gets their hands on your money. So, with that, that's how much money you can make. You just multiply them together. However, it would be better if we could graph this. Now, to graph this, it works out fairly nicely because since I have x's and y's, those make up points, just like we talked about in the last video. 0, 0, 1, 9, 2, 18, 3, 27, 30, 270. Okay. Now, with that, I could come over here and put them on a graph. Now, my graph, my x values need to go along the x-axis, y values on the y-axis, and in this case, I could go 1, 2, 3, 4, 5. Now, you'll notice my values are going up fairly quickly, so I could go 1, 2, 3, 4, 5, 6, 7, 8, or I could do something else. I could go up maybe by 5s. 5, 10, 15, 20, 25, even up to 30. So here we go. If I don't work any hours, I don't make any money, 0, 0. If I work 1 hour, I make $9. If I work 2 hours, I make $18. If I work 3 hours, I make $27. Now, obviously, for 30 hours, it's going to be up. I did not move over far enough on this last dot. If I worked 30 hours, I would be way, way up here. So what we can do is we can draw a line through our various points, and it would go up or down. Now, in our case, since you can't work less than 0 hours, it's not going to go down, but it will go up. When we talk about graphing functions, one of the things we can always talk about is how do I know if a relation is a function? If it's graph, for every x there's only one y, that means at any point on this graph, I know that if I go over to any number, I'm going up to exactly one number. Over, up, over, up. Let's go back and let's look at that circle that we drew in the last video. In this case, if I go over to 2, 1, 2, I don't know where to go because I could go up to this point here, which is on the circle, or I could go over 2 and I could go down. This fails as a function because even though I can graph it, I'm not sure where the points are. In this case, if I go over, I know I'm going here. In this case, I know I'm going here. But over here, could be down, could be up, go back, could be up, could be down. Don't know which way to go. So this is not a function. This is just a relation. This is a function because I know exactly where to go. Just as another note, if I have just the graph without the equations, what I could do is I could say, is this graph a function? And is this graph a function? Now, the answer here is yes, it's a function. Because as I go over to any value, I can go up to one single value. I know exactly where to go. I know that if I go over to 1, I'm going to go up to right here. Over here, I'm okay if I go back here, I know I'm going down. If I go over here, I know I'm going down. If I go over here, I know I'm going down. But if I go right here, I could be down, middle, up. There are three places that I intersect this line. 1, 2, 3. The way we can tell whether something is or is not a function, it's called the vertical line test. Now, because math people are not creative, the vertical line test, not shockingly, involves a vertical line. So here we go. Could I draw a vertical line, a vertical, of course, meaning up and down, through the graph? If every vertical line I draw only touches the graph in one spot, then it is indeed a function. However, over here, I'm okay. But as soon as I try here, 1, 2, 3 spots. 1, 2, 3 spots. Even here, 1 spot, 2 spot. If there's any place where a vertical line crosses in more than one spot, it is not a function. So a vertical line test, only one y for every x. All right, so it matches up with every time I put in 0, I get 0. Every time I put in 1, I get 9. 2, I get 18. Here, if I go over to a certain x, I could go up or I could go down. That's going to break the rules. So that is graphing functions.